None of these authors were really experts in mathematical astronomy or the procedure of Vakya system of computation. So there are large number of errors and misspellings, so that just from the current editions, you cannot make out what is the astronomical calculation really correct. Anyway, now I will just give over 2-3 minutes a summary of one Vakya computation where this number is occurring. This is how to calculate the position of moon using Vakya system. So you start with how many for some day, say today. You find out how many days have elapsed since the beginning of Kali Yuga. In 20th century, this number will 18 lakh and 19 lakh days, something like that. In 12th, 13th century, it was 15 lakh days. Now you subtract this number. That subtracting this number, you go to a day very near to you. When Chudamani Ullamudiyan was being written, he was living in some time in a Kali Dina 15 lakh 70,000. So they subtract 15 lakh 65,000, only 3-4,000 remain. So that kind of a day on which moon and the apogee were together at sunrise. So this number is to be subtracted because we know that the day on which the Kali Dina was so much, 15 lakh 65,411, moon and the apogee were together. So subtract this. Then whatever remains, the 3031 and 248 are numbers which are related to what is called the anomalistic revolution. That is, both moon and apogee complete full revolutions. So in 248 days, they complete 9 revolutions, and in 3031 days, they complete 11 revolutions. Then do a reverse calculation. You divide by these two and find out the final remainder. That remainder will be smaller than 248. So that will give you the number of the Chandra Vakya that you have to use. So as I said, there are 248 Chandra Vakyas. You get to the point where the sunrise, apogee and moon were together, and you just use the Chandra Vakya to calculate that. So to that you have to add various numbers because of the complete distance traveled by the moon in these complete revolutions. So various numbers have to be added first. That is, these quotients obtained in these divisions have to be multiplied by numbers which are given in the text. To that, the Vakya longitude, which is like the Girdan Shreya, 0, 12, 0, 9. 12 degrees 9 minutes should be added if it is the remainder is 1. So this is the Vakya system. So this is a verse from Hoisington's edition. We do not have time to read the verse. So there are phrases occurring here, both in the verse and it's a traditional commentary whose authorship we don't know. So in this particular verse, this is 13 in Hoisington's edition in chapter 8. One phrase which occurs is Mannan Veed Shul Kulam. So it is occurring here in the commentary. It is occurring here also. Kulam. Palliyoni. Palliyoni is another number. And then Erirma. That is the third number. So now use the system that I told you. Ma is 1. Na is 1. V, that is Dirga E. I, that is 4. So 1, 1, 4 in the opposite order. Du, that is U, that is 5. Shu, that is I, U, that is 6. Ilku, Ilku again, U is the vowel, so that is again 5. Lam, that is again I is the vowel. So 15,65,411 is given by the Tamil phrase Mannan Veed Shul Kulam. It has a meaning also. I am not a good Tamil scholar that I can explain all this to you straight away. Palliyoni. Pa is 1, Li is 3, Yo, I, U, A, I, O, O, 0, Ni is 3. So Palliyoni is 3031. This Erirma, A, this is Dirga. I have not put the bar above that. I put a hat to show the Hrasva A above E. So this I use in the Sanskrit way as Dirga. A is 8. Ri is 4, Ma is 2, Erirma is the famous 240. And then in the another verse, so now this verse is wrongly printed in Satyabhama Kameshwaran's edition. It's properly printed in Hoisington's edition. Whereas the next part of the process is correctly printed in Satyabhama Kameshwaran's edition. It is wrongly printed in Hoisington's edition. So this is the reverse process. You have to multiply each of those quotients by various numbers that I showed you again earlier. You have to multiply them by this. So many rashis, so many degrees, so many 31. So all those things are stated in the next verse. I'll just explain one of these Tamil phrases to show how this number is. Manno kari chetro natta. Ma is 1. No, O is 0. So this corresponds to 1 second, 0, 1 seconds. Kari, ka is 1, ri is 3. So 31 kalai. So it is 1 vinadi, that is 0, 1 vinadi, 31 kalai. Then setro. A is a, I, u, a, that is 7. O is 0. Setro. O are both 0. So 0, 7 bhage. That is bhaga, which is natta, that is a, that is 11. And so many rashi. So many rashi, bhage, kalai, and vinadi. So they are all there in this verse and in this commentary. So similarly, this number comes. Here, the commentary is explaining what this number is. Whereas there, this commentary was just using this phrase, Mannan Vidishul Kuram, in that previous verse. It was not explaining. But here the commentary is explaining what this number is. But it doesn't do it for every verse. It does it for few verses. So, this is the way these great astronomical texts are using this new system. We will not go into further discussion of how these numbers are used, but some final few comments. Now, neither the text, that is neither Chudamani Ullamudiyan nor the commentary, is stating what is the system of numeration. And in few instances, the commentary gives explicitly the. And the editors are also not writing anything. So Hoisington doesn't say anything. Satyabhama Kameshwaran doesn't say anything. So we could only find in one book this key for this. Anyway, we knew the key because we knew the Chandravakyas, about which I will talk to you in a minute. So there is a book written by a famous scholar in 19th century called Munam Pandey Krishna Joyce. He has written a book called Panchanga Ganitam, which is a part of Jyotisha Ganita Shastra in 1897. So there he is explaining that I is 1, I is 2, E is 3, E is 4, 2 is 5. Of course, he is omitting that O also is 0. So this book has it. And this thing that I explained to you in Sanskrit, these Chandravakyas, now we can write them in Tamil also. And that is what was done very soon. I think Chudamani Ullamudiyan itself is talking about this Chandravakyas. I'll just show you the Sanskrit Chandravakyas in a minute. Shreya 01203, Denavashrihi 0249, Rudrastu Namya 1622. So now you see the Tamil Chandravakyas. There are 248 of them. They are called Panchanga Vakyas. Hoisington's book separately gives it, but that is not in relation to Chudamani Ullamudiyan. Krishna Joshi is also writing a general book on Vakya system. But the set of Chandravakyas given in Hoisington's book is different from the set of Vakyas given in Krishna Joshi's book. But both of them denote the same number. So you have 248 Chandravakyas, two different versions of it. One in Hoisington's book, one is in Krishna Joshi's book. And there is another book similar to Chudamani Ullamudiyan called Bhimeshwara Ullamudiyan or Bhimeshwara Ullamudiyan. This was composed around 17th century. That has also been published, which are closer to Krishna Joshi's list. I have just listed 3 of these ones. Professor Pai and Professor Ramnathan are preparing a critical edition of all the 248. So Vinnor Nathan, V is 3, so that is this 3. No, O is 0, Na is 2, Ta is 1. So 12 degrees, 3 minutes. That is the version in Hoisington. Vitto Nathan. So again, V is 3, To is 0, Nathan is in 12. So Pain Ponindan here, Veito Nitan here, Varai Pukoya here, Vana Vulokam here. So all the 3, both of them represent the same number. So basically, the Tamil tradition did come up with a very robust system of representing numbers in Tamil Chayul, in Tamil poems, and also for these Chandravakyas in astronomy, in mathematics. It is as robust and as flexible. Flexible because you have several possibilities for the same. You only have to keep the vowel. You can attach it to any consonant and it has the same numerical value. In Katapayadi, you can have 2 or 3 consonants which have the same value, ka, ta, and pa, same. You can attach any vowel to it. So both are very flexible, both are very robust. And to some extent, this vowel system can be extended to other Indian languages also with the suitable modifications. The important thing is that there is such an advanced text of astronomy published in India, but unfortunately, most of our scholars do not know what it contains. A book like Chudamani Ulla Mudiyan. Today, from retrospect, we are seeing it is prior to Vakya Karana and it is giving for the moon the correct procedure. Vakya Karana improves upon what is given in Chudamani. And Tirukoti Nambi himself is reproducing what is there in Sanskrit books. So what is that Sanskrit book also? We don't know. But the Tamil tradition did come up with a version of Katapayadi and used it very beautifully in devising Chandravakyas and all these things. This is something all of us should be aware and be very proud of. And so we have now 4 systems of numeration: the Bhuta Sankhya, the Aryabhatiya system, the Katapayadi, and this Uyirelitya Swara-based system. So all these are very useful in representing numbers in literature, which makes it very easy for you to remember the numbers. In fact, the entire sign table of Madhava is given in 6 verses. Shreshtam Nama Varishtanam Himadre Veda Bhavanam. The very complicated sign values are all given in just 6 verses. So things like that, this was a very ingenious system our Indian scholars used. And slides with Professor Usha, any of you who are interested can take a look. And soon enough, I think this paper will be available. Maybe once it's ready, its final version is being prepared by Professor Ramanathan and Professor Pai. We can share it with Professor Usha also. And that has all the other references. These books, Satyabhama Kameshwaran, is available on the net. But it's very difficult to decode it without knowing the Vakya system because there are lots of errors and things like that. I hope I have conveyed something of the excitement of Tamil astronomy text with you. There are many advanced texts of astronomy in Malayalam. We were not aware of such texts in Tamil, and now the Chudamani Ulla Mudiyan and Bhimeshwara Ulla Mudiyan, there are indeed quite a few texts, and perhaps lots of manuscripts may be there. And maybe there are even just manuscripts of Chandravakyas also. Anyway, thank you very much. Questions. I will stop sharing now.